Standard form is a little bit different than vertex form. On this page, standard form is written right here. Ax squared plus bx plus c. A is the number in front of your x squared, b is the number in front of the x, and c is the number by itself. Your a value is still going to do everything that the first number has done in the previous forms. So if that's a positive number, your graph is going to open upward. If it's a negative number, then your graph will open downward, like in this second picture. So A still controls whether the graph opens up or down. It still controls the stretch or the shrink, so how narrow or how wide the graph is. With vertex form, we were able to see what the axis of symmetry was because we could see the vertex in the formula. In standard form, you cannot see the axis of symmetry just from the equation. You're going to have to calculate it. And the formula is x equals the opposite of b over 2a. I am going to try to say the opposite of b over 2a as many times as I possibly can today, so that hopefully the opposite of b over 2a gets ingrained in your brain. Opposite of b over 2a, opposite of b over 2a. Have you felt like you've heard the opposite of b over 2a a few times already? Should I make all of you say it together? I think we totally should. I'll pause the video. Would that make you feel better? Here, I'll pause the video. Okay, that was fun. That was lots of fun. The vertex is on the symmetry line. So the x coordinate of the vertex would be the same as the axis of symmetry. So the first part of our vertex is the opposite of b over 2a. And then the second part of your vertex is your maximum or your minimum value. To get that number, you have to plug the axis of symmetry into the equation that you're given. The maximum or minimum is the y value of the vertex. If you have a graph like the one on the left, that point is considered the minimum because it's the lowest point on that parabola. The graph on the right, that vertex would be called a maximum because it is the highest point on the graph. There's good and bad things about every form. The really great thing about vertex form is that it shows us the vertex. The bad thing about vertex form is that we then have to pick another x value and plug it in to get another point. The bad thing about standard form is we have to do quite a bit of calculation to get the axis of symmetry in the vertex, but the good thing about standard form is c. Your c value is your y-intercept. So standard form will tell us specifically where this graph crosses the y-axis. This is really helpful if I give you a bunch of quadratic equations and a bunch of graphs and tell you to match them. If you see that one of them is blah blah plus 7, and there's one graph where it crosses the y-axis at 7, you can match those two together. So your c value is your y-intercept, which is very, very helpful. All right. So as you get familiar with this, you probably won't need to do this first step. The first thing I'm going to do is identify that A is the number 3. What is B? -6. And C is 1. Okay. Our first step is going to be to find the axis of symmetry, which the formula is the opposite of b over 2a. Now, why do you suppose I've been calling it the opposite of b and not negative b? Right, because negative is weird. So sometimes our b value is positive, and then we'd plug in the opposite of that, which would be negative. In this case, our b value is negative, so we are going to plug in +6. So our axis of symmetry will be +6 divided by 2 times our a value of 3. You will need to do a little bit of mental math, because if you try to type into your calculator 6 divided by 2 times 3, it will do 6 divided by 2 and then multiply it by 3 when you really need to do the 2 times the 3 first. Our axis of symmetry is 1. So our axis of symmetry is x equals 1. That means we have a symmetry line going through our graph vertically at a value of 1. Our next step is to find our vertex. Our vertex exists on that line. So our vertex, we already know that the first part of it is 1, because that's the axis of symmetry. If we know that the first part of our vertex is 1, how do we find the y value of our vertex? We need to plug it in. So I know that my vertex, the first part is 1. I need to plug that in there and there. And having a calculator to help you with this can be very helpful. Let's shift it over. Okay. You should try to use parentheses around each x, especially if you're plugging in a negative number. We aren't plugging in a negative number here, but it's worth saying. So I do 3 parentheses 1, close my parentheses squared, minus 6 parentheses 1, close my parentheses, plus 1. The most common error in standard form is plugging in the x value of your vertex and getting the wrong number because you did some user error in using your calculator. I got -2 as the y value of my vertex. So my vertex is at 1, -2. Right now you might be looking at the graph and thinking, oh my gosh, we've already done a bunch of work and we only have 1 point on the graph. This is ridiculous. The great thing about standard form is once you get 1 point on the graph, you are practically done, because the rest of this is super, super simple. Your next step is your y-intercept. Our y-intercept is 1. It came directly from our equation. So my y-intercept is right here at 1. Anyone want to take a guess what we're going to do next? We're going to mirror it. We're going to reflect the y-intercept over the axis of symmetry. So this is 1 unit away from the symmetry line, go 1 unit in the other direction.
Why is it 1?
Well, it's 1 unit away from that symmetry line that we drew. So 1. Why is the value of the y-intercept 1? Because our c value is 1. Okay, once you have 3 points, then you can sketch in your parabola. Is it shocking that this parabola is so skinny? No, because our a value is 3. That's a vertical stretch. That's going to make the parabola skinny. On your assignment, it's going to ask you for the axis of symmetry. It's going to ask you for the vertex. So here's our vertex. It's also going to ask you if the graph has a maximum or a minimum and what that maximum or minimum value is. So because our vertex is at the bottom, this would be considered a minimum. So you can circle minimum. And that number is the y value of your vertex. So our minimum is at -2. That minimum is going to help you when you do your domain and your range. Okay, hardest question of the day. What's the domain? All real numbers. You all are rock stars. The range is related to your minimum or your maximum. So y and then something to do with -2. Are the rest of the points above the minimum or below the minimum? Above, so y is greater than or equal to. Okay, so I'm going to try to highlight all of the things that are related to each other. I think we did that. Blah, 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 blah. All right. For example, B, I'm going to change it a little bit. Basically, we're just going to stick a negative in front. So the equation is going to be negative 0.5x squared minus 4x minus 2. So we're just changing this because I want you to see one with a negative in front. Okay, let's try this problem together. First step, axis of symmetry. The formula for that is opposite of B over 2A. So what is our B value? Our B value is negative 4, so we need to put in positive 4 over 2 times negative 0.5. If you're doing this in the calculator, do 2 times negative 0.5 first, negative 1. So this is 4 divided by negative 1. That means our axis of symmetry is at negative 4. So our axis of symmetry is x equals negative 4. And let's draw that dashed line in that will help us later on. Once we know the axis of symmetry is negative 4, we've done half of the work to get our vertex. The first part of our vertex is the axis of symmetry. To get the rest of our vertex, we need to plug that negative 4 in. Now this is a negative number, so parentheses are going to be important. So watch how I put this in the calculator. Negative 0.5 parentheses, negative 4, close your parentheses, squared, minus 4 parentheses, negative 4, close the parentheses, minus 2. Should be 6. So our vertex is negative 4, 6. That means that we are going to have a max or a minimum value at 6. That y value of your vertex is your maximum or minimum value. We'll wait for a minute to circle maximum or minimum once we see the picture. Now we're almost done. Our y-intercept is negative 2 because that's our c value. This is looking like a wider graph, but we kind of expect that. You are going to have to count on this one. This point is 1, 2, 3, 4 units away from the symmetry line. So here is our parabola. And now that we see it, we see that that vertex is at the top. That means it's a maximum, so our maximum is 6. Your last step is to do the domain and the range. So, I'm being sarcastic here. Hardest part of this problem, what is the domain? All real numbers. Sarcastic because it's always all real numbers. And the range is linked to the maximum or minimum. So because our max is at 6, y something 6? Less than or equal to, because all of these points are below the maximum.